Hola, mis estudiantes. It's Mr. Hogan here, and I've got a quick video all about multiples, greatest common factor, and least common multiple. Let's first take a look at our riddle that we have here. You'll notice that there is a 1, a square, and a 2, although it does not look the normal way that a 1 and a 2 look, but that's something definitely to keep in mind for our riddle. That's your first hint. Alright, let's take a look at the multiples. What does multiples mean? Well, multiples means, if we had to put the simplest definition, we would say that multiples is like skip counting. So whenever I see the word multiples, I'm going to think skip counting. So if I wanted to find out what are the multiples of 3, for example, I would first start with the first multiple of 3, which would be 3. And I'd skip count by 3s, meaning I'd keep adding 3 each time. So 3 plus 3 is 6. Another 3 is 9, 12, 15, 18, and so forth. You'll notice the list of multiples never ends for the multiples of 3. Eventually you just have to stop. So here I have listed out 1, 2, 3, 4, 5, 6 multiples of 3. Now the reason why they are also called multiples is because you use 2 factors to multiply together to create a multiple. So for example, I actually did 3 times 1 for this first multiple. This is my second multiple, so I actually did 3 times 2. This is 3 times 3. 3 times 4. And so forth. Notice I used 2 factors to multiply together to get a multiple. A multiple is really kind of like the product in multiplication. But the reason why you need to know about multiples is, for example, I might ask you, is the number 30, is that a multiple of 3? Well, the way that you'd figure that out is you would skip count by 3s, or you think, do I know 3 times anything to give me 30? And in that case, I do. 3 times 10 gives me 30, so I know that 30 is a multiple of 3, because in my list of multiples, my 10th multiple, if I kept going, would be 3 times 10, and that would be equal to 30. So 30 would appear in my list of multiples. So those are multiples, and we don't want to get confused with factors, though. So factors are the 2 numbers that you multiply together to get a multiple or a product. And I've always told you, when you see factor, you think factor rainbow, because you've never heard me say multiple rainbow. It's always been factor rainbow. And when you see multiples, you think skip counting. So always keep that in the back of your head, just in case you ever get mixed up between the 2 of them. Now here's another one that we talked about, GCF. Now the GCF is an abbreviation, an acronym essentially, for greatest common factor. And so when we're talking about greatest common factor, obviously now we're talking about factors, not multiples. We're talking about factors. And so when I see the word factor, I think factor rainbow. And so essentially, if I'm trying to find the GCF of, let's say, 3 and let's say 10, if I'm trying to find the GCF of 3 and 10, I'm going to, since I'm thinking about factors, I'm going to make a factor rainbow for 3, which I know 3 is a prime number, because the first 5 prime numbers is 2, 3, 5, 7, 11. Notice how I said 3 in that list. 3 is a prime number, so I know that my factor rainbow for a prime number only has 1 factor pair. P-R-I-M-E, only factors are 1 and me, so 1 times 3. So my only factor pair is 1 times 3. Now for 10, if I was making a factor rainbow, I would have 1 and 10, 1 and me. And then I know that 10 also has another factor pair because it is an even number. And all even numbers have a factor of 2 and something else. In this case, it's 2 times 5. So the number 10 has a factor rainbow that includes an arch for 1 times 10 and for 2 times 5, which makes 10 a composite number. Now knowing that it is prime and composite helps me to create the factor rainbow, but it's not necessarily going to help me figure out what is the greatest common factor. I've done my factors now. So now I'm going to think about common. Well, common, if I wanted to know, what do Miss Whalen and Mr. Hogan have in common? Well, most of you would start thinking about how we are similar in terms of that we are both teachers, that we're awesome, and whatever you want to say. But when we're talking about common, we're saying, what do they have that is similar? And so in both lists, they both have a 1 as a common factor. They don't both have a 3 as a common factor. So now we've taken care of the word common. Now it says greatest common factor. So of the ones that we've circled, here we only have 1 that's circled, but if we had a bunch that were circled, we now have to figure out which one of those factors is the largest. In other words, the greatest. So in this case, our GCF, this is a relatively basic, simple problem, just for instructional purposes. GCF equals 1 because that's the largest common factor that 3 and 10 share. And sometimes it might not seem very large, but that is the greatest common factor because there's only one common factor that these two numbers share, and it just happens to be the greatest as well. Now let's take a look at LCM. LCM is not related to factors because notice there is no F in LCM. This is actually least common multiple. Now notice I said multiple, so when you hear the word multiple, no longer are you thinking about factor rainbows. You are now thinking about multiples, meaning skip counting. So I'm going to start thinking about skip counting the second that I see LCM. And so let's say I have, let's do 3 and 10 again, just to determine the difference between what GCF and LCM are. Our work is going to look completely different because now we're dealing with LCM, or in other words, multiples. So when I think multiples, I'm thinking skip counting. So I'm going to skip count by 3s and skip count by 10s. So I'll start with 3, 6, 9, 12, 15, and I always say to do at least the first 5 multiples. And then do the first 5 over here. 10, 20, 30, 40, and 50. Now, I would now think about if there's anything that's common here. And I don't see anything that's common. They do not have a common multiple. So that doesn't mean that I'm necessarily wrong. It's just that I know that multiples will never end. They keep going on and on and on. And I've only done the first 5. So now I might extend it to the first, let's say, 10. So I'm going to extend 3 to the first 10 multiples. So I've done 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. Now I'm doing 3 times 6, which is 18. 3 times 7, 21. Or you can skip count by 3, so I'm going to add another 3, which is 24, 27. And then my last multiple for the first 10 is 30. Now, I'm not going to necessarily stretch out 10 all the way out to the 10th multiple because I already see a match. And so, since I see a match, I see 30 in both lists. I know I can stop because I have figured the common ones. I've listed out all the multiples, and now I'm just thinking about least common multiple. So obviously, if it's the very first one that I have found, the very first match, it's going to be my least common multiple because that's the smallest one. If I was to keep going, I could tell you that 60 would be another common multiple, but 30 is smaller than 60, so least common multiple, LCM, in this case, equals 30. Notice that the work for LCM and GCF are completely different, even though we are doing it for the numbers 3 and 10. So the GCF for 3 and 10 is 1, looks completely different, factor rainbows for GCF. And then for 3 and 10, the LCM is equal to 30, and looks completely different because now we're doing skip counting. So something definitely to keep in mind. And that's one reason why I say to never mix the two together. Multiples, skip counting, factors, factor rainbows. Think about that. Factors are the two numbers that you multiply together to create a multiple or a product. Alright, now this is a relatively short video. Lucky you. So I'm going to end this video with one more look at our riddle. And in the beginning of the riddle, or the beginning of the video, I showed you this riddle and I talked about how this was a 1, this was a square, and this was the number 2. Now, I'm going to do something really cool on the computer. So I'm going to flip it just so you can see that, this has actually now been flipped. So this is actually in reverse order. It's important that it remains how it was originally, but I wanted to show you that. Notice how this is kind of written backwards. And that's kind of the last clue I can really give you. 1 squared 2, and that is written backwards. So maybe try and read from right to left rather than left to right. And that might be able to help you. All right, and that is the end of the video.